Alright, so I'm going to start this lesson today on Desmos because we're going to be looking at the graphs of these functions, and it's really difficult to graph these things by hand. You might be forced to on the test, but you have graphing paper and such, but I don't have it on my drawing surfaces, so I'm going to just use Desmos, but you still get the point. So this function we have here is the absolute value of 2x minus 3, and outside the absolute value is minus 2. Now, how would you graph this? Well, as I said in the previous video, you would have to notice that this slope is 2x, and notice that this one is negative 2x. Now, that's important, but that doesn't really mean much because we don't know where to put the slopes at, because it depends on what your x value is. So the first thing you want to do, similar to what you do with a quadratic a quadratic in vertex form, you find the vertex. Now the vertex is the same way that you find vertex in parabolas. So notice here, this is negative 1 point, not negative, this is 1.5, that's the and negative 2. That's the vertex of the absolute value function. All right. From there, it's actually pretty straightforward. What you do is you just draw a simple straight line, like as if it's a linear function. Anything to the you draw it based on you just draw the parent function. It would just be a straight line. So this would be just the slope of 2x. On the other side, you would have a slope which is negative 2x. If we compare it to the other two, to the functions that is composed of them, we can see how they intersect here, right? Notice how these parts, they just the red part, which is negative 2x plus 3 minus 2, this creates the left hand side of it, and just the normal 2x minus 3 minus 2, this creates the right hand side of it. So that's how these two graphs are combined into making this one. So the general rule, the method to drawing these graphs is to find the vertex. From the vertex, you just draw a linear line, like you draw a linear equation. So you just take the slope of it and you just draw a straight line. In the end, it looks like a V-shaped. All right, so now if you want to look at the negative version, you just flip it upside down, right? Now everything's just backwards. So when everything on the left used to be negative 2x for the slope, now it's just positive 2x. So that's pretty good. But these are the basic examples which you can practice. It's not that difficult. But let's look at different ways of combining absolute values and into our functions. So let's say we have this one. This is our normal graph of x squared minus 2. Notice how this negative 2 is below the x-axis, right? So nothing's wrong with that. What happens if we put the absolute value around f of x? Notice here, you see how everything negative, if the y value is negative, it actually points upwards, right? What's the reason of this? Well, recall that f of x that's the same thing as saying the y value. If we put absolute values around it, that just means all of our x values must be positive. So if we take this point, for instance, 0, negative 2, our y value is negative 2. However, because we put in an absolute value, it has to be positive 2. So this just flips upwards. When you have the absolute value around your f of x, everything below the x-axis, you flip upwards. All right? Next, let's look at our function g of x. G of x is our function x minus 2 to the third power. Notice how this is just cubic, except we just shifted it over by 2 units. What happens if we put the absolute value inside of our function? So instead of absolute value of f of x, we say g of absolute value of x. What we get is this function, this red function here. Notice how this function, it's symmetrical. It's basically an even function, right? This is an even function because the f of x equals f of negative x. That should make sense, right? Because by absolute value equals plus or minus x. So why do we get this? Well, notice how this is absolute value of x. We notice here at 2, we have 2 and 0, right? If we look at our original g of x at negative 2, I'll have to scroll down a little bit. We have negative 2, so negative 4 to the third, that's negative 64. So somewhere really down there. However, we notice with our red function, we also have negative 2 and 0. Why? Because if we put negative 2 into here, we would have g of absolute value of negative 2. Absolute value of negative 2, that's equals to 2, right? That's the definition of absolute value. But then we would just get g of 2. G of 2 is, we already have it defined here, right? So we just look at what g of 2 is, and then we just graph it on the other side. So if you have the absolute value inside of the function, so you have g of absolute value of x, what you do is you take the right-hand side, you just take the right-hand side of your function, and then you just flip it over so that you draw the other side of it, so it's symmetrical around the y-axis like this. Now we put a negative sign here. You see how it's the reverse. We take the left-hand side of it and we flip it onto the right-hand side. That should be pretty good. Now for our final example, we're going to combine both of these. We have h of x equals x minus 2 to the third minus 2. So you see here, it's just this cubic that I shifted all the way down here. What happens if I put both the absolute value around the h of x and inside of the h of x? Well, we're going to click on this, and we see this. So how would you graph this? Well, we're going to take this step by step. We can ignore the outside stuff first, and we can just graph just the normal f of x, h of x right here. So in orange, we have the absolute value, which inside of it, which I just did with g of x. So what we do is we just take everything on the right-hand side and we flip it over to the y-axis. It's symmetrical. All right, so that should be pretty straightforward. Right? Okay, so now if we look at our original the function with both of them, we notice that everything is also positive, right? If we take a look at this, we see that everything between negative 3.26 and 3.26, this stuff is all negative. The absolute value surrounding them, it flips it upwards onto the y-axis, above the y-axis, x-axis, so that's positive. That is why our function looks like this. It flips upwards. It flips upwards like this. Hopefully that made sense to you. If it didn't, try rewinding it, or even better, go to Desmos and try creating a bunch of functions for yourself and playing around with these absolute value functions surrounding the function or inside of the function, and try playing around with it until you get the hang of why stuff is like that. Now the method I just showed you, which is you just first take the absolute version of it. You should be doing this. Like, this is the first step you do when you see this thing, the green part. When you see this, you should always be thinking of graphing this, right? You break your problem down step by step so that it's easier at the end. Because here, all you have to do from here is just flip everything down here all the way up here. And that's pretty simple. So hopefully all of this made sense for you, and I'll see you in the next video.